Okay, this is lesson 6.1, and this is about trends in graphs. A graph is a visual representation of the relationship between two variables or quantities. It shows how one quantity changes with respect to the other. How we describe this change is called a relationship or a trend. And there's two parts to describing every trend. You need to say what's happening to the y value with respect to the x. So is it increasing or decreasing? And you have to say how it's increasing or decreasing. So at what rate? So I'm going to show both of those for 4 examples. And I'll highlight with different colors so you can see the two parts I'm talking about. First one, Jack's babysitting earnings. As the number of hours Jack babysits increases, what's the relationship with earnings? Well, as hours worked goes up, earnings goes up. So we would say his earnings increase. So that takes care of what's happening to the y values. And you can tell it's increasing because, well, the line goes up from left to right. And the increase is at a constant rate. Now, the reason it's at a constant rate is because, well, the rate of change is constant, which means it's going up by the same amount over time. And we know it's going to be constant when we have a linear relationship. So if we ever have a line, the rate is going to be constant. Let's try B. Amount of a compound interest investment. Over time, the amount of a compound interest investment, so we have to say two parts. We have to say whether it's getting bigger or smaller as we go left to right, and it's increasing, so we say increases. At A, and then we have to describe the rate. So increases, and what's happening. Well, it's not at a constant rate this time because we don't have a line, but if I break this down into a couple lines, you can kind of see what's happening. So I'm going to take my ruler, and I'm going to take this part of the graph and say that it's like this line, and then I'm going to take this part of the graph, and I'm going to say it looks like a line like that, and the last part I'm going to turn it into a line like this. And that'll kind of help you see what's happening. If we look, this line's relatively flat. The middle line is a little bit steeper, and the last line is even steeper. So as it's getting more vertical, it's increasing at an increasing rate. So how do we know these two parts? Well, how do we first know it's increasing? Well, it's increasing because it curves up from left to right. And the reason we know it's at an increasing rate is because the curve gets steeper. If a curve gets steeper, it becomes more vertical. That's an increasing rate. Let's try the next one. Temperature of a cooling coffee cup. Over time, the coffee temperature, well, what happens? Well, it's going down, so we have our first decrease. And it's at A. And this time, our curve starts steeper and gets flatter. So that's called a decreasing rate. So we have our first decreasing rate, and we have our first decrease. It's coincidence that decrease and decreasing rate, increase and increasing rate went together. I'm going to show you all 4 types of curves. And we know it's decreasing because it curves down from left to right. And it's a decreasing rate because the curve gets flatter. Now, if you were given a question that said describe the relationship, you just need to write decreasing at a decreasing rate. We don't need these two. This is just for our lesson, so I can show you why. Last one. Now, this last one's a little unique because it kind of has two parts. The first part, our curve goes up, and then it goes down. So we have to break this into two explanations. The first part, it looks like it's increasing, but it's getting flatter to a peak. So we would say, as fertilizer use increases, crop yield increases at A, and since it's getting flatter, that's a decreasing rate. And it does that until it gets to this point at the top, which is called a maximum. So crop yield increases to a decreasing rate to a maximum. And then, once it reaches the maximum, it decreases because we're curved down at A. And since our graph is flatter at the top and then steeper at the bottom, this is an increasing rate. So what do we got here? We've got increases and then decreases, and the rate is decreasing and then increasing. So there we have all four types of curves we could expect. Let's review those curves real quick. So we've got increasing at an increasing rate, so that's curving up and getting steeper. We've got decreasing at a decreasing rate, that's going down and getting flatter. We've got increasing at a decreasing rate, which is going up and getting flatter. And we've got decreasing at an increasing rate, which is going down and getting steeper. And that's about all the trends that we can have. We could have a flat line that doesn't increase or decrease, and we would just say stays the same. And there's no rate because it's not increasing or decreasing. All right, let's flip it over. Trends or relationships in a graph. Are used to justify decisions and make predictions. So let's try two examples here. This graph shows the number of births in Ontario from 1945 to 2005. Describe the trends in the graph. And if we look, it looks like we're going up, and we hit a peak, and then we go down, and then we go back up, and then we just kind of go down. A little bit of up at the very end. But if we broke this graph up, we could break it up into kind of three realistic sections. We could say there's a beginning. I think I missed an N. A middle. And an end. And in the beginning, it looks like it's just linear. It's going up. In the middle, it looks like it's curving. And at the end, it looks like it's just kind of going down. We can get more specific and we can break it up into intervals. For example, from 1945 to 1960. Well, that would be from this dot to this dot. What's happening from that dot to that dot? Well, as time goes by, the number of births are going up. And it seems to be a relatively constant rate. little bit slower here, a little bit quicker here. But overall, we could say it's at a relatively constant rate. So to describe this section of the graph, we might choose to simplify it by just connecting the dots and describing that trend to represent the overall trend. So we might say from 1945 to 1960, the number of births increase at a constant rate. From 1960 to 1975, that'd be from here to here. This one looks a little bit more curved. If you wanted to connect it with a line, I think that'd be okay too. But let's use the curve. So what's happening here? Well, we're decreasing. They decrease at a decreasing rate. From 1975 to 1980, that's this dot to this dot. We're just flat. We're not going up or down. So we would say number of births remain constant. From 1980 to 1990, that's 80 to 85 to 90. Looks like we're curving up. So that's an increase. And they're increasing at an increasing rate because they're getting steeper. It's curving up. Increase rate. (1990 to 2000). That's 90, 95, 2000. I'm just going to call this constant. We could say it's curved. Let's say it's curved. Curving down. So number of births decrease at a, and we're getting steeper as we go down, so decreasing, increasing rate. And at the very end, we've got a slight increase. But it's a line because it's between 2 points, so at a constant rate. Some of these you could describe it slightly differently. Like if you wanted to say this one was more straight, you could say constant rate, and I don't think you'd be wrong. If you wanted to describe from here to here as curved, you could say that, and I don't think you'd be wrong. It's just more about kind of drawing on it and then representing what you've drawn. If you've drawn a curve, you should describe a curve. All right, last example. Use the graph to predict the number of Canadians in each age group in 2010. The aging of Canada's population, we've got number of people in millions, and we've got years, so that would be 2000. 1, 2, 3, 4, 1, 2. So it's asking us to make a prediction about 2010, which would be right here. So what do we think is happening? Well, age 15 and under, we were going down, and then we were going back up, and then we were going back down slightly. I don't know, if you wanted to continue this, we might expect maybe something around here. Might go back up, I don't know. 60 and over seems to be going up at this linear rate, so you would just kind of continue that. You'd expect it to be here. And this one's going up ever so slowly, so you might just kind of continue that and make a prediction about there. So you might expect these to actually cross. It might go back up and they might be about the same. Either way, it's up to you to make the prediction. There's no right or wrong, as long as you show it and then describe it. So it looks like 5.2 million And 60 looks like it got over 6, so we call it approximately 6.1 million. And 80 plus looks like it just got over 1 million. There's our prediction. What decisions might the Canadian government make in response to the trends in the graph? Well, it looks like we're having a lot more people that are 60 and over. So the Canadian government would probably want to increase money support to a couple things. Well, what happens when you're 60 and over? 65, 55, somewhere in that region, you're going to retire. So retirement savings. And when you get to 60 and over, that's where healthcare becomes even more important. So we might say increase support to healthcare. I think that's pretty good. All right, that's lesson 6.1. Thanks for watching, and I'll see you in 6.2.